Welcome to the 28th presentation of the Athlete Richardson Irvine Clarke Prize. I'm Kevin Hardy, Executive Director of the National Water Research Institute. NWRI, the Clarke Prize Executive Committee, and the Joan Irvine Smith and Athlete R. Clarke Foundation are pleased to award the 28th Clarke Prize to Dr. Shane A. Snyder. Dr. Snyder is a professor of civil and environmental engineering and the Executive Director of the Nanyang Environment and Water Research Institute at Nanyang Technical University in Singapore. However, as noted in his nomination, Shane is perhaps most importantly known as a compassionate and personable character that always enjoys sharing his knowledge with others, which is precisely what he will be doing in just a very few moments when he presents the featured element of every Clarke Prize event, the Clarke Prize Lecture. The Clarke Prize and NWRI also rely substantially on NWRI's public agency members. If it weren't for the financial and technical support of our members, NWRI would not exist at all. Therefore, please join me in thanking the NWRI member agencies for their trusted and transformational support of the Clarke Prize, NWRI, and the many communities we have and continue to serve. NWRI's public agency members also guide the Institute through the NWRI Board of Directors, which is ably chaired by IRWD's John Withers and vice-chaired by IEUA's Steve Eli. OCWD is represented by Director Kathy Green. OC SAN is represented by Director and Huntington Beach Mayor Kim Carr, and LADWP is represented by Razmik Manukian. Thank you all for being a light in my professional life. Water is life, and thus water is about people. And so NWRI is about people too. People who have committed their lives to improve the quality of life, not just in their own communities, but in villages, towns, and cities they may never see or realize benefited from their work. People like my wife who make me possible. People like you who engage in our work and who are the light in my personal life. I miss you all, and I look forward to the day when we can gather to award the Clarke Prize to another amazing person, in person, with family, friends, and colleagues by our sides, our bonds strengthened by the bizarre and tragic experiences of a global pandemic. Until then, I wish you all a healthy and prosperous remainder of 2021 and pray we may come together again in person in 2022. Now join me in welcoming James Irvine Swindon, Director of the Joan Irvine Smith and Athlete R. Clarke Foundation.
Thank you for having me once again to the Clarke Prize. It's my great pleasure to speak on behalf of the Irvine family. As many of you know, our family has been involved in the county since the mid-1860s. In 1863, my great-great-grandfather and several partners acquired 3 Mexican land grants that ultimately became what is now known as the Irvine Ranch. Originally, it was a cattle operation, and then they supplemented by bringing sheep in, but he was faced with many of the issues that we're faced with today, mainly water. And in 1863, the year he bought the property, was the start of one of California's major droughts. He suffered additional droughts during the 1800s, and then in the late 1800s, my great-grandfather decided to diversify the ranching operations into agriculture. And during his tenure, from roughly 1890s up to the 1950s, he suffered 4 droughts, the longest of which was 9 years. But he was very persistent and continued operations through 2 world wars, the Great Depression, and dealing with additional issues on the ranch. During that time, his son, James Irvine, also my grandfather, helped drill over 1,000 wells on the property, and Irvine Lake was established as a reservoir for the operations. My grandmother also lived on the property, and it was her great opportunity to be able to learn about ranching from her father-in-law. And this she took to heart. During her lifetime, she had 5 farms and ranches spanning from Virginia to the Hawaiian Islands and also in California. In the Hawaiian Islands, she had one of the top botanical gardens, and her property in Visalia, she had a cotton allotment, and the property had the distinction of being across the street from the work camp that John Steinbeck made famous in his book, Grapes of Wrath. She was also incredibly astute in business, and her property in the San Fernando Valley became the cornerstone of the Northridge Shopping Center. She dabbled in politics, but she was all about the land and about the water. And for a number of years, she served on the State Agricultural Board under Ronald Reagan. My grandmother then passed the mantle on to my mother, who also had grown up on the ranch and had interactions with her grandfather, and she became very interested in water. Consequently, she was one of the individuals that helped establish the University of California, Irvine, the Irvine Museum, and the National Water Research Institute. It was her dream that the Institute would be a collaboration between utilities, regulators, and scientists to develop a new, healthy sources of drinking water. She was also instrumental in developing the Dryer well field, which created a permanent source of underground water for the county and now serves over 50% of the Irvine Ranch Water District's members. In addition, she founded the Joan Irvine Smith and Ethel R. Clarke Foundation, which helps support the activities at the university and the National Water Research Institute, and it is our great honor to once again sponsor the Clarke Prize in honor of my grandmother, Ethel Richardson Irvine Clarke. At this time, it is my great pleasure, on behalf of the Joan Irvine Smith and Ethel R. Clarke Foundation, to present to Dr. Shane A. Snyder the 2021 Clarke Prize. Congratulations. In addition, I have a book on my mother's life, which will give you a history of our family and also water with significance to the development of Orange County. Congratulations and thank you.
Wonderful. Thank you so much. Good afternoon. I'm very honored, I'm very grateful to be here today as the 2021 recipient of the Clarke Prize, and I appreciate James Swindon, who just presented me with this beautiful medallion and a wonderful book that talks about his family's legacy here in Southern California and that relationship to water. Before I get started on my speech, I also wanted to thank the foundation. That would be the Ethel Richardson Irvine Clarke Foundation, which made this endowment possible, and also the creation of the National Water Research Institute, or NWRI. And I'd like to thank Kevin Hardy, who has put up with a lot in the logistics for me to be here. I was actually on a family visit to the United States and stopped by on my way back to Singapore. I also want to thank the NWRI Board of Directors, particularly John Withers, and the Clarke Prize Executive Committee, including my friend George Jabanaglos. And of course, all the member agencies of NWRI, but today particularly acknowledge Orange County Water District, where we're using their beautiful facilities, which I've been many times, and an agency who has also won the Lee Kuan Yew Prize in Singapore at Singapore International Water Week. So with that, I'm going to quickly go through a bit of a history and tell you about how I ended up working in this field of water and why I find it so rewarding and why I'm passionate. And I'd like to do that by covering three major points today. So the first point is reflected in my title. All environmental substances, be it contaminants or natural products, occur as complicated mixtures in the environment. They don't occur one at a time. Now, some of these mixtures are completely benign. Others can be very toxic, and yet others can be very beneficial, which is something I'm going to show you today, which I think will be a bit of a spin from the normal. Second of all, as you'll see in my own education, and now as I've become an academic in two different institutions, one of the key things I've learned is that multidisciplinary, cross-cutting research teams have the greatest synergy and the greatest ability to provide new knowledge, to make new breakthroughs, and to take bigger risks that could really change the world. And I'll show you that as well today. And last of all, I hope some of the students are watching, some of our young water professionals. And my last point, as you'll see, is that the experiences that you go through, in your life journey, whether they're good, bad, never going to be perfect. But you can learn from those experiences, and they can make a huge difference in your career and your ability to help others. So go for it. So with that, I want to talk today about mixtures, and I'm going to tell you a bit about how I ended up in this field. I had a long, strange trip, I would say. So with my journey, as all of us, it began with my parents. So my mom and dad were kind enough to email me some photos while I was here in Orange County. That's me as a little kid. Looks like I'm putting up some kind of tantrum. It's pretty typical, I think, still even today, I guess. And you know, one of the things that I always remember about being a kid is that love for water. And I think all of us as kids think back, but for our family, it was particularly, we were involved in water. We were out boating, kayaking, canoeing, and my father even built this swimming pool for us at our family home. So, you know, I always enjoyed the water. Even now I enjoy it in Singapore, where I'm on a small island surrounded by water. So this is the home I grew up in. Now, I wasn't in this photo, I hope you realize that. So this house is about 200 years old. And it started out as a hotel, restaurant, I think there was a saloon there, and it became the medical office for my grandfather, who practiced medicine here in an office on the first floor. Now, why do I show this house that I grew up in? Well, one of the things that I've learned along the way and has influenced my life is that our family was drinking groundwater. Now, this is a photo here. You can see the well. This was a hand-dug well, of course, very, very old well. And I never understood until it was too late that that type of water was susceptible to influences based on human activities. And in our case, our water was unfortunately impacted by something we couldn't even see. So now I'll show you another photo of the old house, and you almost see the sign for my grandfather's medical office. But I'm trying to show you kind of the background. You can see the rural environment, the snow, some farms, and then kind of a row of trees in the background. Now, beyond that row of trees, in 1974 was constructed a landfill. Unfortunately, much of this landfill was not lined. There were improper materials disposed, and the water table became contaminated. So much so that many of the homes that used to be nearby this landfill when I was growing up were purchased, they were knocked down, they were destroyed, and eventually my parents also sold the home that was in our family for multiple generations, and we had to move. So being a teenager and moving is never a good time, and at least that was in part attributed to water contamination. So it really surprised me, and it began to pique my curiosity how something could move through the ground and contaminate our water. Another part of growing up, most of my memories, my mom and my dad, my brother, my sister, just absolutely wonderful, very fortunate. But one area I was not so fortunate in was childhood asthma. So when I was a kid, I had really bad asthma. I would keep my mom awake at night, I'd be crying, I couldn't catch my breath. It was really something terrible. Now, this also, of course, piqued my scientific interest later in my career, and I'm going to tell you that story today briefly. So this is a graphic showing the increase in eczema, in asthma, and in childhood asthma over the years. Now, what we're showing in this graphic is that this is something that seems to be growing and growing at a very, very rapid rate. And one of the theories is that in the 1930s and earlier, we really didn't have refrigeration, we may have had fewer siblings, antibiotics came into the picture. We were living a very different lifestyle ahead of the 1930s. So I popped along here somewhere around 1969, and again, as I grew up as a child, I suffered greatly from this childhood asthma. But I made it through high school, and I took some time off. I worked at a hospital in a chemistry laboratory. That may not surprise some of you. And then I decided to go to Thiel College. It's a small private school. It was founded in the early 1800s. And I went there because I liked medicine. I thought I was going to study medicine. I had it in my head that's what I was going to do. And these small liberal arts schools are fantastic for that. So just one of the pictures of one of the older buildings at Thiel College. This is somewhere halfway between Pittsburgh and Erie in western Pennsylvania. And one fellow in particular who really influenced me was Professor Bennett. Now, Professor Bennett was the organic chemistry teacher, and a lot of people were scared of Dr. Bennett, but he really took me under his wing. He helped me win then an American Chemical Society award for undergraduate achievement in organic chemistry, something I never thought would happen. And I ended up changing my major from medicine to chemistry. And then the most miraculous thing happened, something that changed my life, these pinnacle moments where something really happens, that someone tells you something. And Dr. Bennett told me, you know, Shane, you should think about going on for a PhD because, you know, you have enough GPA, it seems like you have the enthusiasm. And I said, yeah, but I really don't want to take any more student loans. I'm pretty much in debt. He said, no. PhD, you know, free tuition and you'll get a stipend. I said, I'm in. I want to do that. I can't believe free education and maybe even enough money to afford a sandwich or something. So that was around 1994. And at that point in time, I had made up my mind, I'm going to switch geographies. I'm going to move to the West Coast. Somewhere from the Rocky Mountains to the Pacific Ocean. I'm tired of this East Coast stuff. I'm going to move to the West. Well, all that changed when I met Professor John Giese. Now, in my tour of potential graduate schools, I had looked in Washington State, in Colorado, I looked in Utah, and the very last place, the very last person I needed to meet was Prof. Giese at Michigan State. And after I spoke to Professor Giese, I think for the first 10 minutes, I knew for sure this was the guy I wanted to work with. And he told me about something I had never heard of, and that was endocrine disruptors. So John told me that in the Great Lakes, there were problems with birds being able to reproduce. Of course, the legacy of DDT and polychlorinated biphenyls, but particularly this interesting finding that chemicals like DDT could act like estrogen in the animal and make them unable to reproduce. So this, to me, was something that just blew my mind, and I thought for sure this is what I want to work on. So, as I started my graduate program, you know, when we're at Michigan State, you can see this very mighty fine research vessel that Prof. Giese provided for me, and we began working on the Great Lakes. And hopefully you can kind of see, you're going to see this kind of device. It's a little bit green here. This is a homemade device that I built to extract water in situ. So we needed to extract the organic chemicals from the water to do this kind of comprehensive evaluation I'm going to talk about, to find out what exactly was causing this impairment to the aquatic and terrestrial wildlife around the Great Lakes. And I need to thank one other person. This is Dr. Dan Villeneuve, who's a very successful scientist at the US EPA. Dan, if you're watching that photo at the top, you know exactly what that's about. You know, he's always a generous guy. And in the second, I think, more recent photo of Dan. But Dan taught me everything there was to know about in vitro bioassays, and I became very passionate about that, but without his help, would not have made it there. So, 1994, 1996. I'm in graduate school, Michigan, cold weather usually in the winter, studying the Great Lakes. And I received a very fateful phone call from the National Park Service at Lake Mead, Nevada. They said, we have discovered with the US Geological Survey these fish that were impacted by endocrine disruptors. You can roughly call them hermaphroditic fish, not quite scientifically correct, but I think people can get their mind around the fact that the male fish were exhibiting exposure to estrogens of some sort, but we didn't know what these were. And this caused great concern for the city of Las Vegas. Las Vegas, at that point in time, was one of the fastest growing cities in the world, and also, you know, using almost entirely Lake Mead water for the drinking water. So the Southern Nevada Water Authority was kind enough to fund a series of projects which became my PhD. So you can see I have a bit of an upgrade. We have that same kind of device for taking samples in situ, but now using National Park Service boats on Lake Mead, beautiful blue skies and warm weather. Southern Nevada Water Authority was kind enough to even increase the funding we received to go to larger scales, So we started extracting, if you can imagine, 100 liters of water using self-made solid phase extraction cartridges, that we would concentrate that down to a few milliliters and be able to do bioassays and non-targeted analyses, something that we talk about a lot nowadays. So I've shown these slides literally for my PhD defense, and I dug them out just for the Clarke Prize. But back in the day, what you're seeing here on the top is an analytical standard for a pharmaceutical. In this case, it's phenytoin. And on the bottom is the mass spectrometry that we saw in Lake Mead water samples. And it goes on. We can show another one. We had things like DEET, the insect repellent. And one we talk about a lot nowadays is tris-chloroethyl phosphate. So we had perfect matches between analytical standards, mass spec libraries. But for me, this is back in the 1990s, I was quite shocked. I thought, well, I don't take those medicines. I don't know how I contaminated my samples, what's going on. Now, this is admitting, as a student, maybe I hadn't been following the literature close enough, because actually in Europe there was quite a bit of work happening. But in the States there was very little since the 1970s, and that work was largely, I think, forgotten by this point in time. The other thing I mentioned that I learned from Dr. Villeneuve and others at Michigan State was this work on in vitro bioassays. And this just blew my mind completely. That we could use a human cell. Now in this case, these are called MCF7 cells. They're human breast cancer cells that have been modified to produce light. So when they bind with estrogen from the environment, whether it's the estrogen naturally or a synthetic chemical that acts like estrogen, they produce light. And that light is very sensitive, very quantifiable, and it can tell us about the mixture of chemicals, not just one, but any chemical within that mixture that can upregulate that human natural receptor. So that's what we did. We collected water from Lake Mead, from parts of Michigan. We extracted and concentrated the organic chemicals, then we exposed them to the human cell lines. If we saw activity, we would begin to fractionate. I'm not going to talk much about that, but we could separate the molecules by their molecular weight, their solubility, their volatility. And eventually we came up with some interesting answers. In fact, I presented this at the CTAC conference in 1997, and there was a reporter in the room for ESMT, the American Chemical Society Journal, and they wrote this wonderful piece. This was published on January 1st, 1998, and it starts out with, for the first time in North America, high levels of natural and synthetic hormones in wastewater have been linked to endocrine disruption in fish. So for me, that was great. I was a grad student. We got a lot of publicity, maybe too much publicity about this. And of course, what we're dealing with here are the wastewater treatment plants in Las Vegas discharging into Lake Mead. Now, this was also my first foray into water reuse. Before Las Vegas, I had no idea of the value of water. I took it for granted. But in Las Vegas, they very cleverly use advanced water treatment systems to help purify the wastewater. They return that water to Lake Mead, and for every liter they return to Lake Mead, they can withdraw another liter. That represents, as last I knew, about 50% of the water supply, a very critical water resource. But now there's something challenging, something new that the county and the city wanted to address. And along with the estrogens came the pharmaceuticals, so we made the front page of a magazine called Resource Magazine in 1999, and the title of the article was Bad Medicine. Now I stole that from Bon Jovi, so that kind of dates me a bit, but nonetheless, it was an interesting time for us. And of course, beyond the media coverage, we published our papers. It took a little while to get that done, and again, I thank Dan Villeneuve who helped me write these papers. But we published two seminal papers in '99 and 2001, where again, what I'm showing here at the top, you can see this kind of yellow line. This is a chromatogram. It's actually liquid chromatography with fluorescence. And below it is the amount of estrogenicity as measured by the human breast cancer cell. So when you see these light blue bars, and the red lines are the statistical significance at 99%, you can see there was a lot of estrogenicity if you look at the left pane. But you also see a peak that's like off scale. That's nonylphenol. That is the chemical I thought for sure, I would have banked whatever low amount of stipend I got at the time, that nonylphenol was causing this effect in the fish. But I was wrong. Plain as that, I was wrong. And it ended up being E2, which is natural estrogen, all of us have, women more than men, and EE2, which is ethinyl estradiol, which is a synthetic estrogen predominantly used in oral birth control medication. So this was quite a surprising find. It proved my hypothesis wrong, and really was, I think, something that motivated me to go on with my work. So as we entered 2000, the Water Authority was doing a lot of work. They're putting more money into studies. They really wanted to solve this, challenge. And one of the things they did, if you look carefully at this very fascinating article, is in the bottom corner they say, but now research by University of Michigan toxicologist Shane Snyder, hired by the Southern Nevada Water Authority. That is not true. I went to Michigan State, not Michigan. No offense to the Wolverines, but go Spartans. And in 2000, indeed, I joined SNWA. So I wanted to thank, recognize the people who really made that possible. And first and foremost is Pat Mulroy. So over the years, I never met a more influential and powerful public speaker, public figure than Pat. So, and I'll talk later about how Pat and I went on my very first trip to Singapore, which is another game changer. But Pat was amazing, super supportive, a risk taker, but yet knowing what she needed to accomplish to keep that city with water. Kay Brothers was the deputy GM at that point in time. Kay was my more day-to-day go-to when I needed something. One of the things I needed that almost no one else needed was foreign travel. I wanted to go on these journeys. I wanted to get the word out about SNWA. We were inspired by what Singapore had done, actually, when we went to Singapore. I'll talk about that in a minute. Unfortunately, Kay passed away in 2017. And then last but not least was my direct boss, Dave Raxey. Now, Dave was a wonderful guy. What a character. And we got along beautifully. He was the best boss ever, and I know that Dave is still doing well, and I thank him again for his help. But it's not just Dave or one person. Of course, there was a huge team. Now, on the left, I show one of these interesting media coverages that SNWA did to kind of talk about this R&D that they were building up, and indeed, they built it up beautifully. And it continues today as a powerhouse R&D organization. And some of the people in the photo are familiar to most of the people in the water industry. Fernando Rosario Ortiz is a professor at the University of Colorado. We have Eric Wirt, Ben Stanford from Hazen and Sawyer, a lot of famous people I got to work with, and that's probably why I'm here today. So, how did we build this R&D capacity? Well, when I first started, I had a desk in the corner of the lunchroom as we waited for SNWA, and they very quickly outfitted us with instruments, with buildings. But we had to also raise our own research capital if we wanted to get bigger. And the people I looked to for that, who have really helped me, was Wade Miller, at the time the executive director of Water Reuse Association. I had a chance to even serve on the board for a while. A great friend of mine, Rob Renner, from was called AWARF at the time, now it's Water Research Foundation. He was formerly the ED. And Jeff Mosier. Now, Jeff and I had a very fascinating and wonderful relationship over the years. When he was at NWRI before Kevin, he helped me get entrenched in various committees. And he was also a bit pessimistic about the bioassays. So Jeff, this is for you. I'm going to show you that yes, it is ready for prime time once again, just like I told you in Harbin, China. So. But one other picture, there's a couple other people I want to acknowledge. So believe it or not, that young guy on the right is me. This was my very first trip in my life to Asia. It was 2002. Fellow in the middle is Taka Sano, I think one of the greatest people anywhere on the planet. What a wonderful man. And even today, Tak continues to give me advice, set me straight on certain issues. And him and his wife who passed away are just wonderful, wonderful people. And then this tall young fellow on the left is Jorg Dravis, another well-known character in the water domain and a good friend and someone I still work with today. So 2002, my eyes were opened to Asia in a way that I didn't know and didn't appreciate the beauty and the kindness of the people, and that really stuck with me. So just another one, another photo, not my best photo, but I had to put it in here, is Rob Renner, myself, and a group who went to Okinawa, Japan to have a meeting with the Japanese and AWRF. So a lot of wonderful travel. And then I just had to show this one that brings me to how did I end up in Singapore. This is a 2008 photo of Pat Mulroy and In-Soo Kim from the Gwangju Institute of Science and Technology in Korea. We met at Singapore International Water Week at the inaugural event. Pat was very kind to fly myself. She flew a bit of an upgraded flight compared to me, but I don't hold that against Pat. That's no worries. But we had a great time, and I remember telling Pat, like, you know, we can do this. We could emulate what Singapore has done in leveraging the billions we've spent in infrastructure to create kind of an economic culture around it. And I think today you can see that Las Vegas and other counties have done things like this. So moving ahead, how do things get rolling? How do we get grants? The grant that was the pinnacle grant for me was this one here called AWRF 2758. This was masterminded primarily by myself and Paul Westerhoff. And Paul, thank you for nominating me for this award. So I got to know Paul. I think he was an assistant professor. I was just a junior guy at SNWA. And as part of that, we were going around the country. We were looking at water reuse facilities. We were learning more about how many emerging contaminants are in water. And one of our stops that was most memorable was here, right here at Orange County Water District. We have Mike Wayner, then we have Fernando Rosario Ortiz, myself, Mark Bonatti, and Ben Stanford. So each of these people well known in their own right. And it turned into just a wonderful project. But it wasn't without controversy. I gave a speech here in Southern California, and after my speech and during the lunch break, a lady approached me and said, "Hi, my name is Martha Mendoza. I work for the Associated Press. Did you just say that there are pharmaceuticals in U.S. drinking water?" I said, "Well, yeah, it's part of the study we're doing." But apparently they found that very interesting and very concerning. And this turned into a congressional probe. I was selected by the American Water Works Association to testify on behalf of the water industries of the United States. And though a very nervous event, I was very proud to be able to represent the water utilities. And at that time, I said it, and I would say it again today. If it wasn't for the water utilities themselves, the agencies, they wouldn't have had the data. Because the data was coming from the funding, from water reuse, from AWRF, and we were actually doing a service for the country, certainly not a disservice. But we went on, we worked with other groups and toxicologists to get more of a perspective of, you know, what does this really mean? Is it really something to be scared about? How do we get all this in place? This comes back to my fundamental point. You know, everything's occurring as a mixture, so how do you get your mind around that? Well, in 2010, I made a decision, and this was one of the hardest decisions of my life. I remember telling Pat Mulroy, well, I decided to go to Arizona. I was looking at somewhere else in the Northeast, but I settled in on going to Arizona. Pat's like, what the heck do you want to go to Arizona? But it turned out quite well for me, and I stayed there for 11 years. Acknowledge just a few people. Jeff Goldberg was the Dean of Engineering, another fantastic guy. He pursued me, convinced me to come to U of A, and always treated me respectfully, a wonderful man. Bob Arnold, now some of you will know Bob. Bob's been around for quite a while. He's a famous character, has done some really wonderful work in the field of water science, and was also helpful to bringing me in. Now I'm going to show you two more people. I'm going to come back to this. Now, this is where multidisciplinary comes in. This fellow, his name is Dr. Fernando Martinez. He was the head of the Bio 5 Institute. So quickly, why do I have a picture of Fernando? Well, Fernando gave a speech and I attended it. And Fernando talked about when he was a kid, he had asthma and how he couldn't breathe and how he'd have to wake up his mom. And I watched that and I thought, my goodness, this is exactly my story. It's the same thing. He's an MD, and he's one of the most famous asthma researchers, I think, in the nation, if not the world. And so after his speech, I went to him and said, if there's something I can do, I would love to work on this. You know, it's not my field, I'm in engineering and water, but maybe there's something we can contribute to, and I'll come back to that. And another fellow, Dr. Jeff Burgess, also in public health, that he was working on firefighters and the risks that firefighters take through dermal and inhalation, including female firefighters, some of which were lactating and their breast milk contained these chemicals. And again, I learned so much from these people who were completely outside the scope of my own work, and I just want to acknowledge them. Now, of course, what can we do if we don't have good students, good postdocs? And this was Gen 1. So this is my Gen 1 team. I'm hiding back behind everybody a little bit. But Tarun Animal in the front, many of you know. Brad Clarke on the end is a professor. And Aija, who's right here in the center, works for, I think, Terry Slifko at Metropolitan Water District. A really wonderful team. And the team got bigger. It looks like I got bigger too, you know. I don't know how that happened, but nonetheless, we had a wonderful team of people. Kevin Daniels kind of hiding in the back, now with Hazen and Sawyer in the front, Ming-Hugh Park, who a lot of people know. And one other person I'll point out is the fellow on the very far side on the left. His name is Mauricius dos Santos, and he was a CAPE scholar from Brazil, meaning he's one of the top students in the entire country of Brazil, and he is the one who is doing the asthma work I'm going to show. So what did we do at Arizona? I don't want to belabor this. I'm probably running my clock up pretty hard already. But you know, we were thinking about what is in water, holistically, not one thing at a time. And of course, especially today in the middle of a pandemic, we can think about, you know, the COVID tracing we've done in the sewage, including in Singapore. But just get our mind around there. It could be anything there, theoretically. So how do we deal with this? Now, I don't want to get into a highly technical speech, right? But of course, we can do targeted quantification. We can use surrogates and indicators. We have fantastic equipment. But I've always been more interested on this left side. Now, that's the non-targeted screening. That's a little bit trickier, a little bit more controversial. But how do we find the next perchlorate if we want to find it? Or the next 1,4-dioxane, or the next NDMA, all of which this state had brought to the expert panel's attention that I've sat on. How do we get ahead of that? And so today I'm going to end this thing with kind of showing you at least what I think is one of the ways we can do that. So this is part of an expert panel that was one with SQUIRP and the State Water Board. Again, thinking like we can do online monitoring. That has advanced so much, and I don't have time to get into that. But especially in Singapore, embracing this idea of online monitoring, the targeted analysis and surrogates, which is usually what I talk about, but I won't do that today, I don't have time. And again, this third tier of non-targeted. I want to show you just one or two quick examples. So this was from a paper we published in 2016. So I already kind of told you about the paper from 1999 and 2001. But here's another example of this effects-directed analysis, bioassays, combined with high-resolution mass. So we were doing a kind of a reconnaissance study in southern Arizona. And GR at the top means glucocorticoid receptor, which is like inflammation, a very common one. AR is androgen, like male hormone. ER is like estrogen, like I already showed you. Now, what you begin to see is that estrogen response, there was some at one of the older wastewater treatment plants, which has now been destroyed and rebuilt, but generally not too bad, not too much of the male hormone. But what is this glucocorticoid receptor? It is a log2. And it's a very potent one, very powerful, very pervasive. And it seems like every time we apply UV light, it goes away. So this was really a fascinating one. We had no idea what this was. So first thing we do, and I always tell the students, always start with a lib review. We figured out that glucocorticoids are among the most prescribed drugs in the world. And in 2014, the US FDA made two of the most common glucocorticoid steroids available over the counter. Nasacort and Flonase are the brand names. These are very common. In fact, I use it quite a bit. You can pick it up almost anywhere nowadays. And we think that was a game changer for the loading into the sewage. So what do? we see this activity, we collect the samples, we fractionate, we separate them into little pieces. We test each of those little pieces in high resolution mass spectrometry. Back in the bioassay, we try to figure out, can we identify the chemicals and can we account for their toxicity, and does it match? And in a perfect world, it matches. So again, I don't want to get deep into this, just to say that this chemical coming from Nasacort called, we'll call it TCA, it makes it easier, was about the predominant glucocorticoid we saw in our wastewater treatment plants. These are all practicing different types of recycling. And we found something very fascinating, and it is a tricky slide, so I'll just tell you that this TCA, if I can show it here, was actually 2 times more powerful in vitro than was the standard. We have a positive control, which was dexamethasone. Many of you may have heard of dexamethasone, very common. This nasal spray was 2 times more potent, and some of these compounds are even up to 7 or even 35 times more powerful than the positive control. So now we have tox data, analytical data, and we were very fortunate that they actually did balance. In other words, we have discovered new glucocorticoids that had not been reported in any literature that we know of, and we could attribute it to the effect. And we went on in Singapore to actually show that it was relevant in vivo. So we went forward to study it with fish, and again, I don't have time for that story today. So what about this asthma and allergy things? Now what we realized here is something that really is just like a game changer. And there's much more information about maybe we live too clean of a life. And why do children from Amish communities, or Amish in general, that are very traditional type farming, not have a high prevalence? They have an extremely low, significantly low occurrence of asthma. And how are these things related? First, we might think about genetics. We might think about heritage lines. But what we realized, and what scientists before us realized, is that when we capture the dust from their homes and we apply that to a mouse with asthma, it can essentially cure asthma. At least the symptoms go away, same with allergies. Pretty phenomenal. So then we thought, well, it's probably microbiome. Well, lucky for me, Fernando Martinez, Professor Fernando, came and said, we might need a chemist here. We might need to take a look at what this is if it's not the microbiome. So what did we do? Well, first of all, I know it's going to be tricky to see this, but first of all, we killed the bacteria, we killed the viruses. As engineers, we're pretty good at killing stuff like that. So we were able to hit it with gamma radiation, heat, etc., and the effect remained. And our funding at the time was coming from the Johnson & Johnson Corporation. I think all of us were like, wow, we have something very interesting here. So we began to do in vitro bioassays. We were actually growing human lungs. It's called an air-liquid interface. So we would grow an epithelial layer of the lung. And we were able to see that we could produce interleukin-6. In other words, we could suppress it by using the dust of the Amish, which was very similar to what we saw in the mouse, except for now we could do 1,000 samples a month instead of 4. And we began to look at these different pathways of proteomics and genomics, and really came up with some pretty cool discoveries. This one I want to spend just a second on. So what this is size exclusion chromatography with organic carbon detection. We use it all the time in water nowadays. Very, very, very common to look at how the natural organic matter changes in its size and its polarity through treatment processes. When we showed this to the pharmaceutical community, they never heard of it. I don't even think they had heard of total organic carbon at that point in time. So it was really exciting because on one side, they were bringing us new knowledge, new information, even about some nuclear magnetic resonance to do structures. On the other side, we're saying, hey, we know how to fractionate. We know how to do in vitro bioassays, and together we came up with some pretty outstanding discoveries. So once we knew the molecular weight range, we could begin to do high resolution mass. And if we look at the total organic carbon, we start with like a lot of carbon here on the top in the big circle. And then we were down to 0.5% of the carbon and still had 100% of the bioactivity. We had eliminated 99.5% of everything else and still had the activity. That's when we knew we were hot on the trail. This has now been patented. The patent was granted in July of this year. So I can say, I guess, that two of the main compounds are these odorant binding protein, Bos taurus, bovine, cow, and allergen Bos D2, also from cows. Now, what's really fascinating is that when we look at cows from a confined animal feeding operation, they don't have this effect. When we look at cows that are happy cows, I remember California has happy cows from back in the day, maybe it's still around, but these cows from remote villages, these cows that were kind of free-ranging, produce these lipocalins that are very effective for controlling asthma. So I'm going to kind of skip through this again, a little bit heavy in the modeling and what we were doing. But at the end of the day, we were able to figure out this pathway, and not only what these proteins are, these glycoproteins, but how they transport things within them. And as you're about to see, I hope I still have a little bit more time left, but I'm going to show you some of Southeast Asia. And what I can tell you that I'm not going to show you here, we have now, every time we see a cow out in the middle of a village, we ask if we can get some of their straw, get a little bit of their dirt. And indeed, we have now demonstrated that this phenomenon is not just the Amish, it's in remote areas where these cows seem to be a bit more, less confined. So, I'm going to go on here and now quickly show you something about Singapore. I think I got time. I'm sorry, I get excited, and I roll a little bit much. So, Singapore. I went to Singapore first in 2011. I was a visiting prof for the National University of Singapore, and since 2018, I'm full-time tenured professor at NTU, Nanyang Technological University. Now, who made that happen? There's a lot of people, and I always attribute it most to Harry Sia. I think everyone knows Harry. Absolutely the best person, a wonderful guy, kind. If I need something I text him, he gets back to me, and was really influential. Even when I was offered the job at NTU, I was really debating if it was a good idea to go permanently or long-term to Singapore, but Harry has been fantastic. When I got to NUS, I was greeted by Prof. Ong Chunam. Many people know him. He serves on various WHO panels, including the WHO reuse guidelines that I was part of, and he was as well. And my current boss, Prof. Lam. So at NTU, he is the Senior Vice President for Research, and I work directly for him running the Nanyang Environment and Water Research Institute, which is about 300 people and an expenditure of about 20-some million USD per year. It is a big operation and keeps me hopping, and Prof. Lam keeps me hopping pretty strongly too. He's like the Pat Mulroy of NTU, I think. So what about Singapore? You probably know a bit about us. We have a population somewhere over 5.5 million, but on a very tiny piece of land, about 728 square kilometers. So we have one of the highest population densities in the world. This makes water very tricky. And that was realized early on by the founder of what we know as modern Singapore, Lee Kuan Yew. And I had the rare opportunity to see Lee Kuan Yew speak at the first International Water Week in Singapore, so I was very proud of that. But Lee Kuan Yew understood that water was vital to the economy, it was vital to the survivability of Singapore, and it shows in the investments the country has made. From the 1960s, they had water rationing, did not have complete sanitation for the population, and today, you may know, they have new water, which they learned a lot from the folks right here at Orange County Water District who won the Lee Kuan Yew Prize, and advances in desalination. And even today, every day, at my research institute, we are working with PUB to lower the energy of desalination, to find better ways to do autonomous systems and sensors and controls for new water and other systems. But we can't control the climate, and the climate is certainly changing. And even in Singapore, where we have an outstanding amount of rain per year, we go through dry periods. This is from 2019 in one of the reservoirs in Malaysia that Singapore uses. And we also have the threat of seawater rise. I mean, Singapore is a tiny island, so even a few centimeters of seawater rise will undo the land reclamation work that took decades to accomplish. So there are a lot of things going on in Singapore. It's a wonderful place to be. They work toward food security, water security, energy security, and a lot of funding that really drives innovation. But we are in some interesting territory. We are located in Southeast Asia. We are near the equator. We have 650 million people in SEA. This is a picture of Manila in the Philippines, which isn't very far away from us in SEA. And sadly, you know, there's about 140 million people that don't have access to reliable and safe drinking water in Southeast Asia. And in general, in the Asia-Pacific region, the Asian Development Bank has estimated that maybe up to 80% of all our wastewater is discharged without any treatment whatsoever. So there's a lot of opportunity and a lot of work. So I mentioned the Institute. I'm not going to go in through our Institute. You can read about it online if you're so interested. But I want to show you one piece of it. And that is the philanthropic part. I want to end with that. You know, one of the greatest joys I've had in working at NTU is this ability to place the best technologies we can into the hands of the people who need it the most. So this is where we've worked. I thank three of the major people, Mr. Lee Poa, a wonderful good friend, this Chief Executive Officer of the Lien Foundation, which gave us the endowment. We have a lifetime endowment for NURI. One of the family members, Lawrence Lien, who's also the founder of the Asian Philanthropic Circle, and a good friend, Stanley Tan, who is a very vibrant man who's always driving for more philanthropic contributions, particularly for Myanmar. And Stanley also arranged for me to meet President Barack Obama, which was one of the highlights of my career. So thank you, Stanley, for that. So how do we do this? We have a big analytical core. I don't want to go into that. But what can we do with it? What can we do to change things? One of the things we're working on is Nepal. I have fallen in love with this country, but they have big challenges. You probably know Mount Everest is there, the Himalayan mountains, the water starts very pure, very clean, but as it flows through Kathmandu, the water quality deteriorates, and we're trying to learn more about the point sources, and can we build some example systems to help them clean up this river. Another spot that I get to work in is beautiful is Chiang Mai in Thailand, and it's quite a tourist destination, but they have the Mai Ping River, which is considered the most contaminated river in Thailand, and the royal family has asked for help. So we're studying this river, we're studying the groundwater around it, and we're looking for where we can make the most impact by building a demonstration scale system to show that it can be done, that we can clean up the water. Biotechnology is huge for us at NURI. That's an area that I work in. We are looking at new ways to do animox. We are looking at industrial treatment. Food waste is a giant area for us I can't get into. And of course, being the head of the Institute, I got to bring in my favorite thing. We're really advancing our work in bioassays. So how do we do philanthropic work around this? Just two quick examples. In India, we built a food waste system for an agricultural community where they can convert this waste into biogas and use that biogas for the community. A much larger one that we built was in Sumedang in Indonesia, in the mountains of Indonesia. They make an absolutely delicious organic tofu. But in that process, they're discharging to a river. The high COD basically killed the river. We captured that wastewater, converted it to biogas, and we now provide biogas for 92 households 24 hours a day. And our most famous project, this is in Sri Lanka, another country I think is just wonderful to visit. Kandy Lake is a UNESCO World Heritage Site. They have a very famous Buddhist temple there, but they didn't have adequate sanitation. We built an example system for them, including floating wetlands, and we won several awards for this. Later, JICA and the World Bank funded full-scale sanitation for the city of Kandy. We like to think that our early work influenced that decision. Membranes, again, I'm not going to go into the membrane work. NURI is one of our biggest areas, is membrane discovery. But how do we get those membranes to the people who need them? And a lot of times we're scared of membranes, right? A little bit expensive, it take high pressure. But we worked on a hollow fiber nanofiltration membrane that we deployed in Mandalay, Myanmar. And the water there was horrifically hard water. It also was full of pathogens, and we knew that NF, nanofiltration, was the right tool. But how to get that? So we worked with a local SME called Century Water that had already commercialized Singaporean technology that was tested by PUB and others, and we deployed it before the political unrest, which is very sad right now in Myanmar, and we're happy that we're still producing water. Another example, this is in Yangon, another community that there was once a really bad hurricane, people moved inland. It's a bit of a rough area, and their water is horrible. So we had to put in an RO system. You can kind of see the water quality here, but we had to be able to remote control and monitor that RO. And we did it. Again, we won an engineering award for it. And that system, I'm happy to say, is still producing water, even though they've had gunfire just on the other side of the fence behind me. Green chemistry materials, catalyst, reductive processes, oxidative processes, things I love to do, but I won't get deep into that. I'll just show you one example I think is pretty cool. This is in Chiang Rai in Thailand, in the northern mountainous region where they call the hill tribes live. Their water source was intermittent when they were trying to get runoff. We helped them find a river, but it's a very high turbidity one, bring the water in. And we challenged our company partner. We said, look, we know sand filtration works. Well, we've been doing sand filtration for a long time. There's nothing wrong with it. But could you guys compete against it for cost and maintenance and reliability? And I was very pleased that Ovivo stepped up to the plate and provided a silicon carbide flat sheet membrane system. Now we think, first you're like, whoa, that's super high tech. Thing's super simple. We could clean it with a high pressure wash. We could keep this thing running very easily. And if you look at the total cost over the lifetime, it is probably cheaper than the sand filter, at least cost competitive. So it's a very exciting one for us. I mentioned my love for Nepal. I know I'm running really out of time here, but they have some of the worst arsenic you can imagine in the southern part of Nepal. Now this time it was a relatively low-tech solution that they came up with, but the main part of this was education. The people didn't realize they were drinking something that absolutely impacted them. This is not endocrine disruption. They were missing limbs. They had defects because the arsenic was that high. So we built an aeration system, and for our source of iron, what could we use? We used nails that we tested, and we empowered them with their own hot kits to monitor it. And now we built these at 2 different schools. Modeling, we've done a lot of work in Indonesia where they've had the earthquakes. Some of those earthquakes caused fracturing of the subsurface, lost their water. We had to kind of track that water, find wells, and provide it for them. Very rewarding work. We also helped build this system. This is kind of a reuse system. We're capturing the urban runoff, which includes some domestic or municipal waste, and we infiltrate it into the ground. We use a well, followed by ultra UV disinfection and carbon. And since we've done this, the government of Indonesia has replicated our work, and that's the best thing that can happen for us to be copied. And my last photo from Indonesia, we work a lot with the government. This fellow next to me, you can see my pretty cool shirt. The guy next to me is the king of Yogyakarta. He is the royal bloodline from the beginning, and even he was very passionate about the work we were doing in water. So it's a good, very rewarding. Last, I'm not going to talk about this, just to say, solid waste, circular economy, converting sludge into high-value materials is probably the #1 thing on the New RE agenda for my institute, but I know we're out of time, but there is plenty of material out there for us to work on. There's plastic waste abundantly, and our idea isn't to try to vacuum it all out of the ocean, but keep it from ever getting in the ocean in the first place. So I talked a long time. I'm a little bit scared to find out what the total was, but I was having a good time. I see Kevin's giving me a mixed look there. Anyway, I'm so thankful again to be here, and I hope you remember my 3 key points, right? every time we're looking at pollution or natural products or whatever it may be, it will be a mixture. And I see biological endpoints as the only way to really address what that fundamentally means, whether it's benefiting and helping to cure asthma or perhaps a negative in terms of some toxicity. The multidisciplinary work, I would not be here today if it weren't for those people who kind of brought me into a new world and showed me something different than the normal sticking in my pigeonhole, so to speak. And lastly, building on those life experiences, which is something I did, and with NTU I went for it, and I've had a great time. And again, I'm so thankful, especially to the kids. You know, they had to do a lot, you know, with me traveling and everything, so thanks for the kids. And that's it. So thank you so much for the time. I have little videos if you so care to read more about it. I know we're out of time already, but again, I really appreciate this great honor and to be one of the many laureates, who almost all of them I know and respect. So thank you so much.
That was awesome.
But it was